In this problem, we would like to look at the validity of the limit comparison test for series. We know that this test, just for the sake of, let's recall the test. So the limit comparison test. So it says you have two positive series, so sigma of xn and sigma of yn are positive series. We assume that xn is equivalent to yn when n goes to infinity, which means that we assume that limit of xn over yn is equal to 1. Then sigma of xn is convergent if and only if sigma of yn is convergent. So it's a very powerful test, because in general what happens is, in real analysis of course, what happens, you are given a series and you are looking at convergence divergence of the series, and you have to come up, if you want to use, for example, the basic comparison test, the limit comparison test, you have to come up with another series. And that's especially for the basic comparison test, that's extremely difficult to come up with this another one that will help you decide on the convergence divergence of your original series. The limit test is very interesting because you can use some approximations techniques that we learned in calculus, for example, and that will allow us, for example, to generate this second series. Okay, so here is the case now. If we look at in our example, so we're dealing with sigma. So let us consider the series sigma of minus 1 to the n over square root of n plus minus 1 to the n. If we take n equal 1, we may be in trouble, and therefore we take it from 2 to infinity. Okay? Clearly this series is not positive. Is not positive. And what's interesting is when n goes to infinity, we have easily, that's minus 1 to the n over square root of n plus minus 1 to the n is going to be equivalent to minus 1 to the n over square root of n, right? So that's why I want to study, for example, the convergence of these two series, okay? So obviously, the series sigma of minus 1 to the n over square root of n satisfies, for n between 2 and infinity, it satisfies the assumptions, all the assumptions of the alternating series test. Therefore, sigma of minus 1 to the n over square root of n is convergent, and we can even be precise and say that it is convergent conditionally, because the absolute value will give us 1 over square root of n, and that's divergent from the p-test, okay, or the p-series. So so this one is convergent, and now what we need to prove is, as the problem states, we want to prove, in fact, that the series, so let us prove that the series minus 1 to the n over square root of n plus minus 1 to the n is divergent. Great. So in order to understand what are we doing, let us point out the following. It's just baby algebra. That's minus 1 to the n over square root of n plus minus 1 to the n is equal minus 1 to the n over square root of n 1 over 1 plus minus 1 to the n over square root of n. And for n large, the minus 1 to the n here will go to 0. So in other words, it becomes very small. So we can use the series and see that 1 plus x for x small, absolute value of x less than 1, is equal to 1 minus x plus x squared plus, okay? So in other words, is the geometric series as long as x is small. So in other words, we have 1 over 1 plus minus 1 to the n square root of n is going to be 1 minus 1 to the n over square root of n plus 1 over n plus of 1 over n, which gives us that minus 1 to the n over square root of n plus minus 1 to the n is going to be, now we have to multiply by minus 1 to the n as we saw before. So we have this term here, okay? So we'll get minus 1 to the n over square root of n time 1 minus 1 to the n over square root of n, 1 over n of 1 over n, which gives us minus 1 to the n over square root of n minus 1 over n plus minus 1 to the n over n square root of n plus O of 1 over n square root of n. So the best way, so this will allow us to look at what? To see what? First of all, that this one, as we said, is conditionally convergent. This one divergent by the p-test or the p-series, and this one, as well as this one, are absolutely convergent from the p-series or the p-test, which gives you that this one will be what? Divergent. But in order, so what we are going to do, in fact, is not do it this way, but we'll do something different. So what I'm going to do is do the following. Minus 1 over square root of n plus minus 1 to the n. And then I will take plus 1 over n minus 1 to the n over square root of n. Why did I do this? Because that's exactly what you had here. You have this piece, okay, and this piece. So I took them to the other side, to the left-hand side of the equality, and now I'm looking at what? So what's this? So here, I'm not going to insult the intelligence of anyone. It's just baby algebra, okay? And we will prove, in fact, that this is equal to minus 1 to the power n square root of n over n times n plus minus 1 to the n square root of n, which is also equal to minus 1 to the n over n square root of n 1 plus minus 1 to the n over square root of n. And then we take the absolute value of this, which is equal to the absolute value of this, which is equal to 1 over n square root of n, 1 plus minus 1 to the n over square root of n. And as you can see, when n is large, this is equivalent to 1 over n square root of n, since this term here goes to 0. Now, we can use the limit test, since sigma of 1 over n square root of n, that's sigma of 1 over n to the power 1.5, which is convergent by the p-series, since 1.5 is bigger than 1. And therefore, this tells me that sigma of minus 1 to the n over square root of n plus minus 1 to the n, okay, minus 1 to the n square root of n plus 1 over n is absolutely convergent. Okay? And therefore, we have minus 1 to the n over square root of n plus minus 1 to the n is equal to uh, uh, minus 1 to the n, over square root of n plus minus 1 to the n minus 1 to the n over square root of n plus 1 over n plus minus 1 to the n over square root of n minus 1 over n. So as you can see, this one is absolutely convergent, this one is conditionally convergent, and this one is divergent. And now you can claim that this one is divergent by using the algebraic structure of series. Therefore, as a conclusion, the limit test does not work for general series, only for positive series.